Kannan Gopalakrishnan. He was working as a senior architect at Engineering Design Research Centre, L&T Construction, India's largest construction company. He's also worked on projects ranging from institutional buildings to international airports, apartment complexes to aircraft hangars. He's also attended 3 international conferences and 2 national conferences, and has also presented technical papers at the Jawaharlal Nehru University, Delhi, and the MSRIT, Bangalore. He's also won the national championship at Archaman at the India's largest architecture quiz. Sir Kannan Gopalakrishnan currently runs a design firm, Habitat Design Studio, and he is also a visiting faculty at the renowned architecture schools in Tamil Nadu.
Welcome to UGC lecture series, and this is lecture number 7 in the series subject Structure and Architecture. We are still dealing with unit number 2, wherein we are looking at history of structural design in the post-industrial period. In the previous episode, we saw large span structures and its continuation from the episode 5. We saw the different types of ways in which long span structures can be built, and we saw examples, we saw case studies of long span construction, and we saw the different methods of construction using steel, concrete and composite structures. In this lecture, we will be looking at history of reinforced concrete, and we will be looking at some famous architects and structural engineers and their landmark projects. We will be looking at 2 people in specific. They are Pierre Luigi Nervi and Robert Maillard. Along with these 2 people, there are a few other people whom we are supposed to learn, and consider this again as a 2-part lecture, wherein in lecture 7 we will be looking at the works of these 2 people, whereas in lecture 8 we will be looking at few other very important people. So, let us get on with the history of reinforced concrete. For that, we first have to understand what reinforced concrete is. Reinforced concrete is a composite material in which concrete's relatively low tensile strength and ductility are counteracted by the inclusion of reinforcement having higher tensile strength and or ductility. In simpler terms, there is concrete. Concrete is just mixture of aggregates, bonding material which is usually cement, and water. This concrete itself is a very hard material, and its compressive strengths and compressive stresses are very good. It is a very strong material. In fact, concrete is not a very modern material. In fact, it has been used for over a long time. Even the Romans seems to have used a form of concrete using pozzolana and locally available materials at that particular point of time. The great building Pantheon, Rome, was also made of concrete. But reinforcing concrete was a much later idea, where concrete is reinforced with a composite material, whereas concrete has a very low tensile strength. When the compressive strength of the concrete is relatively very high, the tensile strength is very low. To counteract the low tensile strength, you introduce another material which has a higher tensile strength, make this material into a composite material, and we work in such a way that the compressive strength of concrete with the tensile strength of steel or iron or any other material combines together to form a very good composite material. That is what we are going to do in reinforced concrete, and let us trace the history of how reinforced concrete came into picture. There are different types of structures and different components of structures that can be built using reinforced concrete. You can build slabs, walls, beams, columns, foundations, frames. Not only these, we can also make buttresses, we can make bridges, we can make a lot of other structures. Modern day tank holders, modern day blast proof rooms are being made of reinforced concrete. Soundproof, acoustically treated, fireproof rooms are also being made of reinforced concrete nowadays. Francois Coignet was a French industrialist. He was a pioneer in the development of structural, prefabricated and reinforced concrete. A French industrialist who started working on reinforced concrete. In 1853, he was the first person to build an iron reinforced concrete structure. He did not reinforce the concrete with any other material. He introduced iron into the concrete, and he built a 4-story house in the suburbs of Paris first. He was one of the first people in the world to build a structure using reinforced concrete, and it was as early as 1853, close to 160 years now, 165 years now. In 1854, the very next year, we have this William Wilkinson, who was an English builder, who also reinforced the concrete roof and floors in his 2-story house which he was constructing. He reinforced it with iron which was available. The roof and the floor, the slabs which he was building, was reinforced with iron. His position of reinforcement, actually when you position reinforcement rod, you don't put reinforcement bars all over the concrete. You put it on specific places. To understand where to put is what complex structural engineering calculations are all about. You need to know how much reinforcement to put, and you need to know where the reinforcement has to go. Usually reinforcement is represented in percentage or in kg per volume of concrete. When William Wilkinson positioned reinforcement in his concrete, it demonstrated that unlike his predecessors who previously constructed reinforced concrete, he really had the knowledge of tensile stresses. He really had the knowledge of how concrete works in tension, how concrete works in compression. He really knew the difference between the tensile stresses and the compressive stresses, and hence the positioning of his reinforcement areas was relatively accurate to that of modern way of doing it. Later, Joseph Monnier, a French gardener, was granted a patent for reinforced flower pots by means of mixing wire mesh to a mortar shell. He made a normal flower pot, normal mortar shell, and he took a wire mesh, chicken wire mesh, and he mixed the wire mesh and the mortar shell to form a flower pot, which is very, very difficult to break. He was a gardener, and he obviously had the problems of pots breaking during his lifetime. So he developed this idea so that the pots cannot be broken easily. Who knew this little idea of non-breakable flower pots could be the patent for reinforced concrete and revolutionizing the whole building industry at a later point of time. In 1877, Monnier was granted another patent for reinforcing concrete columns and girders with iron rods placed in a grid pattern. He started reinforcing all the columns and girders and all the thick piers with reinforcement which were arranged in a grid fashion. Not the usual way in which it is being done now after complex calculations, but in a very rudimentary level he arranged reinforcement bars in a grid fashion. Monnier undoubtedly knew that reinforcing the concrete which was there would greatly improve its inner cohesion, but what we don't know about Monnier is whether he knew or not how much concrete is required, how much steel is required, how much iron is required, how much of a reinforcement material is required to make the whole structure very stable, the longevity. We have doubts whether he knew and we had an understanding of all these activities in the first place, but he definitely knew that reinforcement in a concrete will greatly improve its inner cohesion. From the early bare beginnings, we have come out to a great many things that have been achieved in concrete construction. Brutalism was a great style which developed immediately after the World War to make sure all government buildings and all major buildings were done in a very, very quick fashion. The reconstruction of a lot of European cities, a lot of European public buildings were of this style. And from the bare beginnings of reinforced concrete, we have come a long way, and it is time for us to recognize the people who led the campaign of concrete construction. And in that series, we have two very great personalities whom we will be discussing in this lecture. They are Luigi Nervi and Robert Mailliat. Robert Mailliat was a Swiss engineer who lived between 1872 and 1940. He studied from the Federal Institute of Technology, Zurich. Although he was not great in studies, he was not very keen in doing mathematics and calculations and other stuff in his engineering studies. He was rather fond of what he was studying. He was rather brilliant at what he was doing, and he often said that the calculations and the mathematics made engineering a little too boring for his own good. He was very intuitive, and he always believed that intuition in structural design is a very important tool. He went on to use reinforced concrete in an extensive manner, and he kind of revolutionized the use of reinforced concrete. He changed the way arches were built, the bridges were built. He invented the 3-hinged arches, he invented the deck stiffened arches. He also invented beamless floor slabs, the mushroom ceilings for large granary kind of spaces, big huge spaces, and he revolutionized the way bridges were built during his time. Let's go on to visit a few of his projects. First project that we are looking at is Salzgitter Bridge in Skiers, Switzerland. This bridge was built in 1930. The first look at this bridge, look at the picture on the right hand side of your screen. The first look at the picture of your screen gives you an amazing view of the bridge along with the landscape, along with the coniferous trees in the background. A very, very pristine location and a very beautiful image of whatever that we could ever hope for. This is one of the very famous landmarks in the country, and it is one of the few things that makes Switzerland the holiday destination for many people, the dream holiday destination for a lot of people. And this bridge is also being visited by a lot of designers and architects and structural engineers ever since, because of its sheer genius. This bridge is completely made of reinforced concrete. It's an arch bridge, and after about 61 years, in 1991, it was declared an international historic civil engineering landmark. Mallet also built a great number of warehouses and great number of granaries, wherein you need a large amount of space to put all your grains, to put all your produce into that space. So he designed large spaces, huge volumes of spaces, and one of the methods in which he designed huge volumes of spaces is early use of reinforced concrete as mushroom columns. Look at the picture on the screen right now. You see this column where the column branches out from the base. The whole load of the roof is carried towards the column because of these mushroom shaped fangs. The load is carried from the slab to the column in a very easy manner. In the ancient period, we had column capitals, which were the means of transferring load from the slab to the column. In reinforced concrete, the use of monolithic engineering, he has used the same genius of using a column capital as a mushroom capital to transfer the load of the slab to the column very easily. Because of the use of mushroom columns, he has understood greatly the stresses that are occupying in this area. The genius in understanding the stresses is what makes him special in the history. There are a number of bridges which he has designed in his lifetime, and each bridge bears his name in its own different way. Every bridge that he has ever built has his mark on it. He has his own signature on every bridge that he has built. Look at the screen. There are pictures of two bridges, Tavanasa Bridge and the Arv Bridge. In both these bridges, look at the sheer genius of him using the arch, the hinged arch and other elements to make this bridge look aesthetically more pleasing, at the same time structurally convenient. In this Arv Bridge, the pillars that he has used has a typical X-like shape here. This X-like shape, when you look at it in the first time, you will feel that this is not going to take a lot of load, and this is going to crumble under the pressure of the road. But if you carefully see how he has designed it, you will be able to appreciate the genius of his design in such a beautiful manner. Mallet was a genius. He was born in Switzerland and he attended the school in Zurich. Thereafter, he went to Russia, where the industrialization was at its peak. There was a lot of scope for expansion, there was a lot of scope for building. He built a lot of industries, a lot of bridges in Russia. After Russia came into the communalism thing, and a lot of properties were centralized. We were all seized by the government, and all his bonds, all his properties were all seized by the government. He came back to Switzerland with no penny in his pocket and with a lot of debt in the bank. Thereafter, he started building a lot of bridges, a lot of structure. His best works were yet to come after he came back to Switzerland, and these are some of his best works. This is a Zuos Bridge and Staffaker Bridge. Both are arched bridges. The shallow arched bridge shows the true genius of his work. The setting, the size, the proportions, everything looks sheer brilliance. Some of the other works by Mallet, look at how thin his slabs are to support this arch over here. There is an entire floor, and the span is quite thick, quite big. The thickness of the slab is mesmerizing. These are other structures which Mallet has designed. Look at the use of his support elements, the different ways in which he has tried to arrange trusses to take loads, the columns that branch out and take loads at multiple points and then collect all the loads and transfer it back to the base. A genius in creation. Next up, we have another famous architect and a structural engineer, Pier Luigi Nervi. Nervi was an Italian engineer. He was born in 1891 and he studied at the University of Bologna. He was a professor of engineering at Rome University between 1946 and 1961, and he was known for being a structural engineer and an architect at the same time. He has designed several buildings, both structure and architecture. His innovative use of reinforced concrete took him to a whole different level. Even though Luigi was much later in period and chronological order than Mallet, Mallet was elder and he lived in a period that was preceding Luigi, whereas Luigi lived in a period, and his famous works are Stadio Artemio Franchi in Florence, Italy. This was one of the early stadiums which he built. This was built in the year 1931, and he designed the stadium, he designed the stands. Thereafter, there was a later addition which took place in the stadium. There used to be a running court right here, and the running court was removed and additional seats were built to accommodate more people for football World Cup. And this was a football stadium which also housed rugby matches and football matches. This is a famous building which was designed by Nervi. This was the UNESCO World Headquarters in Paris, France. Look at the shape of the building. This is a satellite image of the building from the top. The form, the shape is simply amazing. These are some of the pictures of the UNESCO World Headquarters. Look at the span of this entrance arch. This is one of the interior spaces inside the UNESCO World Headquarters. The use of columns here in a different manner makes the visitor enjoy its sheer beauty, because these columns are designed in such a way that it gives a maximum free space in the bottom for people to walk around, use, sit and do other activities. Whereas in the top, this column becomes bigger and it has an extended bracket which takes in additional load. These brackets take additional load from the middle of the span and then transfers it to the center of the column. So, all the load is kind of distributed through the bracket to the column this way in a genius manner. thereby providing a large amount of space in the bottom for people to work. The UNESCO World Headquarters in Paris was a combined work of three famous architects: Marcel Breuer, Bernard Zerfus, and Nervi. Nervi worked with Zerfus and Breuer to get this whole building done, and even though it was done by three different architects, there was also an entire validation team which is comprised of an international committee of 5 architects, including famous architects such as Lucio Costa, Walter Gropius, Le Corbusier, Sven Markelius, Ernesto Nathan Rogers, also with the collaboration of the very famous Eero Saarinen. Eero Saarinen was the validation expert. He was the judge for many famous projects at that particular point of time, and he was also a part of the validation team in this project. Next up, we have the Pirelli Tower in Milan, Italy. He worked with Gio Ponti on this project. This Pirelli Tower was one of the first buildings which had tapered size, and it abandoned the customary block form. Usually skyscrapers had this idea of taking a square and then extruding that square to form a cube. This is the usual thing that skyscrapers were doing at that point of time. There was a base was usually a square or a rectangle, which was then extruded. That is the form that usually skyscrapers take at that particular point of time. It is one of the very first buildings that changed the way skyscrapers have to look, and it is characterized by this unique structural skeleton, curtain wall facades, tapered sides. This is how the plan looks: the central part, the slightly tapering middle, and the greatly tapering ends, which houses the staircase and the lifts and other services. This is how the building looks. Another interesting building which Luigi designed is Norfolk Scope Center. It's a cultural entertainment center in Virginia. It comprises of an 11,000 person arena, a 2,500 person theater, now known as the Chrysler Hall, and a 10,000 square foot exhibition hall and a 600 car parking garage. Such a large building, and it also looks great. It was built in the year 1971. Along with the waterfront, the building looks simply amazing. Look at the use of its external columns which fly out to support the central large dome that the building has. Some other pictures of the building from the interior and from the sky level, from the top. The use of single columns that support multiple beams, takes the load, transfers it to the bottom. Use of coffers. It's again a view of one single pier, which again branches out into two elements, which becomes thinner at the top, wider at the base, to take the load from the top, transfer it laterally onto the sides. In this lecture, we understood the complex early structural marvels made of reinforced concrete. We also understood the development of the material over the ages, especially during the early times when reinforced concrete was in development stage. We saw the works of legendary architects and structural engineers like Malat and Nervi. These are some of the questions which you can try to answer by understanding the lecture. Who were the early pioneers of reinforced concrete and trace their contribution to the field of structure and architecture? How do we know Nervi in the field of architecture, explained with sketches of his most famous works? How do we know Malat in the field of complex structural architecture, explained with sketches of his most famous works? With this, we come to a conclusion of lecture 7 of this series of structure and architecture. Looking forward to meeting you in the next lecture, lecture 8, along with few other architects and structural engineers who have contributed greatly in the field of structural engineering. Thank you.